started. Okay. Is my screen visible again?
Now it is, sir. Yes.
Okay, very good. So if I talk about quant, or
Yes.
particularly cat,
Yes, sir.
so there are few main sections. Like the first one is arithmetic. Did you go through my videos also?
Sir, I hadn't had the time yesterday, sir, actually.
Okay, not an issue. So arithmetic section, algebra section, geometry and mensuration section, modern maths, and number system. I have written these sections as per the weightage in CAT exam. So
Yes, sir.
arithmetic has the highest, then algebra, then geometry mensuration, then modern maths. Earlier, if you go 10 years back, the number system had a bit more weightage, but
Okay.
nowadays just one or two questions, these kind.
Mm-hmm.
So the three sections are very very important for us, not just for CAT, for any aptitude exam. The arithmetic,
Yes.
algebra, and geometry mensuration. And one section is very 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 important. That is arithmetic, right? So it
Yes, sir.
totally depends. Some exams just focus a bit more on algebra, some arithmetic. But yes, if you observe any aptitude exams, you will be able to observe that arithmetic and geometry mensuration have algebra and geometry mensuration have higher weightage, around 70
Mm.
to 75% of the exams, or say 80% sometimes,
Okay.
right? So it varies a bit, but this is a rough structure. What we usually discuss in arithmetic section, if I divide into parts, what we discuss in arithmetic, we discuss the ratio, proportion, variation, we discuss percentages, profit, loss, discount, we discuss this SICI as you said, we'll be discussing TST, time, speed and distance, time and work, averages. These are some major topics in arithmetic section.
Yes, sir.
Similarly, if I talk about algebra section, there are some important topics like we can take it as the linear equations, or say simple equation kind of things. So just take linear equations firstly, slight idea, and linear inequalities also, linear inequalities and modulus part. Are you aware of modulus?
Uh, no, sir.
No. Okay. You are aware of all these arithmetic topics, right?
Yes, sir. Yes,
Okay.
sir.
So algebra, yes, usually commerce students face a bit difficult in algebra section. So linear equation, linear inequalities,
Mm.
quadratic equation. You must be aware of quadratic equation, right?
Yes, sir. Yes, sir.
And we'll be discussing here function also, function and graphs, because graphs are also important for CAT. And we'll discuss that trigo part also here, trigonometry,
Yes, sir.
sequences and series, sequences and series. This is the overall algebra sections. In geometry mensuration, just geometry and mensuration, simple. In geometry, we'll be discussing about the properties related to lines and angles, the triangle, circle, quadrilateral, polygons, right? And in
Yes, sir.
mensuration, we'll be just calculating the area and volume of different shapes.
Yes.
We'll be evaluating for the 2D, two-dimensional shapes and three-dimensional shapes. In the modern maths, we'll be mainly discussing about PNC and probability. You understand PNC?
Permutation and combination,
Yes,
sir.
yes, yes, very good.
Yes, sir. A little bit. Yes, sir.
Yes, permutation and combination and probability. And the last one would be number system and its related properties.
Okay.
Related properties. For some non-CAT exams, number system has some weightage, but arithmetic and algebra is more important in almost all the aptitude exams, right?
Yes, sir.
At least for management level. So this is the rough structure of quant.
Yes,
You
sir.
can note this.
I noted it down, sir.
Very good. Then we can go very fast. Should I save this also? Because as you have noted, I don't think I need to save it, right?
No, sir. Yes, sir. I wrote it down, sir.
Very good. So what topic we should start with?
Uh, Sir, anything. I feel anything that I am a little like modulus. I have no idea about. So I feel like.
Okay, I
Uh,
think we should start with algebra sections.
yes, sir.
Algebra, because arithmetic section you have some idea, so
Yes, sir.
it would be better if we start with algebra. Yes, we can
Yes.
start with honey. In algebra, let's start with the basic algebra portion that I think you are very clear with. Some students do not have that much strong command in algebra section, but I think as per the discussion, you have some basic
Mm.
algebra. In algebra, two things are very important: the constant and variable. Do you understand constant and variable?
Yes, sir.
Very good. What is constant?
Sir, like in an equation, a number is a constant, any value that
Yes,
cannot be changed.
yes, very good. 2, 3, 5 by 7, these are constant. For
Yes.
you also it will be 2, for me also it will be 2. Today,
Yes, sir.
today it is 2, tomorrow also it will be 2. It is not going
Yes.
to change. And the variable is its values changes from equation to equation, right? From place to
Yes.
place. Sometimes you'll get x is equal to 2, sometimes you'll get x is equal to 5 by 9, right?
Yes. Yes.
So the value just gets changed. So variable includes x, y, z. I can take it as a, b, c, whatever, right? Alpha,
Yes.
beta. So all these are variables, and here constant. These are fixed, right? Now tell me few more things. If I add 2 plus 5, it will be what?
7.
7. If I take 2 minus 5, it will be
-3.
very good. If I take minus 5 plus 2, then
-3.
very good. If you have this idea, okay, tell me one more. 2 into 5, it will be
10.
2 times minus 5. It will be
-10.
minus 2 times minus 5, then
10.
very good. So if you have these ideas in simple numbers, the same you can apply for the parts of algebraic expressions also. For example, if you have somewhere 2x square plus 3x 5x square minus 7xy plus 4xy plus 1 by 2 y square minus 7 y square, and I ask you to evaluate this. What you will do?
I'll take x one side and y one side. No, okay, wait.
No, there is no, there is only one
Y.
side, right?
Yes, sir. Yes, sir.
So I just want to be clear here: x square and x square. That means you can add only those parts in algebraic expressions where we have same variables, right? So here the
Yes, sir.
variable part is x square. Here also the variable part is x square. That means I can add 2x square plus 5x square, and it will be what? 7x square.
7.
Correct?
Yes, sir.
Here I have minus 7xy and here plus 4xy. It would be what? Minus 3xy.
X1.
Here I have plus 1 by 2 x y square and minus 7y square. I can evaluate this 1 by 2 and minus 7, and it would be what? It would be minus
Y.
13 by 2, right?
Yes, sir.
Y square. So you got the basic idea that the simple number rules applied in the algebraic expressions also. One thing
Yes,
that
sir.
you have to keep in mind, the variable part should be same, right?
Yes, sir.
That's it. Note these parts.
Yes, sir. Done, sir.
Very good. That means we are clear with the addition and subtraction of the algebraic expression. If I ask you to multiply the algebraic expression, what you'll do? If we have 2x times 3xy plus 7, how will you multiply this?
I'll multiply 2x with both of them, like 6x square y plus 14x.
Very good. So 6x square y plus 14x. We can multiply like this. If I give you something like, this was an example for multiplication. If I write 2x minus 7 times 4x square y minus 7xy square, solve for this.
So yes, 8x 8x cube y minus 14x square y square
Correct.
minus 28x square y
Correct.
plus 49xy square.
Okay, that means you have idea that how to multiply the algebraic expressions, right?
Yes, sir.
Okay, let's discuss now for division. If we have to divide some algebraic expressions, if we if I ask you to divide x square minus 5x plus 6 with x minus 2, divide. Do you know how to divide?
No, no, sir.
Okay, so the idea is x square minus 5x plus 6. I can apply the same logic that we usually apply with numbers. Suppose I have 47, I want to divide it with 3. Okay, so what I do, 1, here I get 3 and I subtract, I'll get 1, 7, then again 5, then 15, I'll get 2 after subtraction, right?
Yes, sir.
I get some quotient, I get some remainder.
Yes, sir.
So here also I can apply the same logic. The thing is, here I have x square and here I have x, correct?
Yes, sir.
Observe
So
the
we get
highest, observe the highest exponent part. That means here the degree is 2, so observe that part, not like that you will start observing this minus 5, right?
yes,
So
sir.
you will observe the highest degree part. So here x square, here x, you'll multiply with what number or say what variable to get x square. If you have x here, I'll have to
X.
multiply with x. That means x times x is x square, so it would be x
Yes.
square. And if we are multiplying with x, we'll have to multiply with minus 2 also, obviously.
Yes, sir.
So
Yes, sir.
minus 2 times x would be what? Minus 2x.
Minus 2x.
And then I can subtract it. If I subtract, the rule is that every sign will get changed. Are you aware of
Yes,
this?
sir. Yes, sir. I am aware of that.
Okay, let's see slightly that why it actually happens. If we have x square minus 5x plus 6 and I am subtracting x square minus 2x, I am saying that sign will get changed. Let's check how. When I open the bracket, x square minus 5x plus 6, it will be minus x square, and here minus times minus is plus 2x,
Plus 2x.
correct? So
Yes, sir.
x square minus x square cancel, it would be minus 3x plus 6. So what I can observe here, I can observe that x square was positive earlier, now it is negative.
Negative.
Minus 2x, it was negative, right? 2x part was negative, now it is positive. How? Whenever we have negative sign, it just changes the original sign, right?
Yes, sir.
But the same does not apply if we are adding the expressions. If we are adding, the sign remains same. Clear?
Same. Yes,
But
sir.
here we are doing the division, so we'll have to subtract it. And here earlier it was positive, it would be negative, and it was earlier negative, now it would be positive. So this x square minus x square cancelled, and minus 5x and plus 2x is minus 3x,
Minus
and here
3x.
we have 6, so minus 3x plus 6. Clear?
Yes, sir. Yes, sir.
Here also we got same. Now we have here x and here we have minus 3x. What we can take in the quotient part? We'll have,
Minus 3.
very good. So we can multiply with minus 3 with x to get minus 3x. So we can write it as
Yes.
minus 3x, and if we are multiplying with x, we'll have to multiply with minus 2 also. So minus
Yes,
2
sir.
times minus 3 will be plus 6.
Plus 6.
And if I subtract it, it will be plus, then minus, cancel, cancel, this is 0. And we are getting the quotient as what? X minus 3, and the
Minus
remainder is 0.
0.
You know the significance of the remainder as 0? Yes.
As in?
The significance is, if you divide any number and you are getting the remainder as 0, that means the number is getting completely divided, right?
Yes, sir. Yes, sir.
That means the x square minus 5x plus 6 is getting completely divided. Clear?
Yes, sir.
Okay, note these parts.
Yes, sir, I did.
Okay, let's take some other example, and I'll here explain you an expression. If we have x square minus 7x plus 12 divided with x minus 5, divide this.
x minus into x square minus 5x minus 7 minus 2x 12 minus 2 minus 2x 10. So 2 is coming as a remainder and x minus 2 is the quotient.
Okay, what you did,
I
x square minus 5x, you subtracted, this cancel, this would be plus, minus 2x plus 12, then you must have done minus 2, right?
Yes,
Minus
sir.
2x plus 10, and after subtracting plus, then minus, and you are getting remainder as 2, right?
Yes, sir.
So here few things. The expression that we are dividing, we generally represent it as xpx, that is our x square minus 7x plus 12.
Yes, sir.
This is called the dividend part.
Yes, sir.
Dividend part. And the gx is usually the divisor part, x minus 5.
Yes,
This
sir.
is called the divisor part. Divisor. And qx is whatever we are getting as the quotient. This is
Quotient.
x minus 2. This is the quotient part.
Yes, sir.
And here rx. Rx is the remainder part, which is 2. This is the remainder. And there is a relation. You know the relation between these?
Yes, sir. Gx into qx plus rx is equal to p of x.
Very good. That means dividend is equal to divisor into quotient plus
Plus remainder.
remainder. This helps a lot. Okay?
Yes, sir.
That means if we want, we can write this expression x square minus 7x plus 12 by x minus 5 as, I can write it as what? I can write it as this x square minus 7x plus 12 as x minus 5 into x minus 2 plus 2 divided by x minus 5, correct?
Yes, sir.
And further, if I want to break it, I can write it as x minus 5 into x minus 2 by x minus 5 plus 2 by x minus 5, and here x minus 5 cancelled, x minus 2 plus 2 by x minus 5. Clear?
Yes, sir.
So in this way, if we want, we can just break the expressions. Note this. This is the relation. This is not like that it happens in only this algebraic expressions. The same applies to the numbers also. As I
Yes, sir.
took 47 with 5, no, I took, I think, with 3.
With 3.
So 1 3 1 7 3 5 15 2. So I can write this 47 as always what? This is 3 times 15 plus 2, and you can check 3 times 15 is 45, 45 plus 2 is 47, right?
Yes. Yes, sir.
Okay.
Yes, sir. I'm done noting it down.
Very good. So these were some very basic concepts related to algebra. Now we can go further and discuss some more. Okay.
Yes, sir.
In algebra, the next thing that we need to be clear with the polynomials and equations part.
Yes, sir.
Polynomials and equations part. You understand polynomials?
I remember learning about it.
Here
Like,
we represent px as a naught xn plus a1 xn minus 1 plus a2 xn minus 2, sorry, n minus 2 plus dot dot dot. At the end we can have an x, just an, because xn minus n would be just 0. And
eh,
so what happens in the polynomial expression? You'll have some constant, you'll have some variable. This is a kind of algebraic expressions only, right?
yes, sir.
And with varying degrees, you'll have degrees like x cube, x square, these kind of things. So
Yes,
in
sir.
polynomials, the general format is this, but few things are very very important, like if you have the degree as 1, if you have the degree as 2, if you have the degree as 3. What is the meaning of degree? Whenever
Um,
I say degree, degree means the highest exponent.
yes, okay.
Highest exponent of the variable. Highest exponent of variable. So here
Yes,
degree is 1. Degree is 1 means what? That means we can have expression like px is equal to ax plus b. Here the degree is 1. How? Here x has no exponent. If nothing is written, that means here it is 1, right?
one. Yes, sir.
That means degree is 1. This particular polynomial is called linear polynomial. Linear polynomial. If the degree is 2, as like px is equal to ax square plus bx plus c. This is called quadratic polynomial.
Yes, sir.
Quadratic polynomial.
No.
And if we have degree as 3, so we can write it as ax cube. These are the standard expressions. Ax cube plus bx square plus cx plus d. And here we call it as cubic polynomial. Okay.
Yes, sir. Yes, sir.
So degree is the highest exponent. Here the degree is 3, here the degree is 2, here the degree is 1. But the highest one is degree 3, right?
Three.
Here
Yes, sir.
the degree is 2, here the degree is 1, highest one is degree 2. So we can divide the polynomial in this way: linear, quadratic, cubic. These are very popular and will be using continuously. And we can take biquadratic also, that means x to the power 4, x to the power 5, these things, right?
Yes, sir.
Noted this part?
Yes, sir.
Okay. Similarly, we can divide the algebraic expressions on the basis of terms. We can divide the algebraic expressions on the basis of terms. Like we can have one term, we can have two terms, we can have three terms, or whatever. Okay, so
Yes, sir.
these three are very popular. Term means what? Term means if we have some expression like polynomial expression like ax plus b, how many terms I can see here? This is one term, this is two term. Terms are separated by the plus and minus, not by
Yes.
multiplication and division, right?
Yeah, yes, yes, sir.
If I write somewhere px as ax square, so here you can just observe there are two terms, but it is not actually, right?
No,
Because terms, if you have something in multiplication and division, they are considered as single term, right?
single.
But
Yes.
if I add here suppose 5, then this will be a separate term, right? So whenever we
Yes.
have to identify the terms, those will be separated with the plus or minus.
Minus.
So for term 1 we can take example like px is equal to 5. This is single term example. We can take
Yes.
example like ax square, single term example.
Yes.
We can take example like ax to the power 4, single term example. Clear? For
Yes, sir.
term 2, px is equal to ax plus b, two terms. We can take example like 2x square plus 5. We can take example, it doesn't matter what the degree is, the
Yes, sir.
term should be 2, right?
Got
So
it.
px is equal to 7x to the power 10 plus 9x square. Here also term 2, it doesn't matter what the degree is.
Yes.
Similarly, for term 3 we can write like ax square plus bx plus c. Here I can see that three terms are there, so I can write like 2x cube plus 5x plus 7. This is degree 3 but term is 3. Okay.
Yes, sir.
Okay. Similarly, I could have taken here 10 also. It is not going to change the it is changing the degree part, but it is not going to change the term part.
Yeah, yes, sir. Got it.
Very good. So the whenever we have term 1, this expression is called, you know what it is?
Um.
Monomial.
Oh, yes, sir.
Monomial. Whenever we have two terms, it is called binomial.
Right.
Binomial expressions. And whenever we have three terms, it is called trinomial.
Yes, sir.
And whenever we say polynomial, they have more terms, right? Polynomial in general
Yes.
sense, it says what? There are many terms in these. But there can be one also, two also, three also, whatever, right?
Got it.
Very good. Let's go further. Noted these parts?
Yes, sir.
Very good. So our major concern is the linear equation, quadratic equation. We don't discuss the cubic equation, but we get some idea about the cubic equation.
Okay.
Okay, we haven't discussed equation yet. Let's discuss about the equation. We discussed the linear polynomial, quadratic polynomial and cubic polynomial, right?
Yes,
Have
sir.
you noted all these parts?
Yes, sir.
Okay, let's now discuss about the linear equation. What is the difference between linear polynomial and linear equation?
Linear equation has a constant.
Linear equation as a constant.
Think.
Okay, just a basic diff. I think you are going there only. Linear polynomial. What was the general expression for this? Px is equal to ax
AX.
plus b. Correct?
Yes,
Whenever
sir.
you equate any linear polynomial with 0 or some other number, whenever you equate this ax plus b with 0, this becomes linear equation. This is the only basic difference.
Yes, sir.
Clear? Ax plus
Yes.
b is equal to 0. This is the standard format of linear equation. And how to
Yes.
solve, and this is the linear equation in one variable, obviously. This is in one
Yeah.
variable. So how to solve the linear equation in one variable? It's very simple. If I
Minus
have
B.
to if I have to find the value of x, I'll write ax is equal to minus b and x would be minus b by a. Correct?
A. Yes, sir.
This is called the solution of linear equation. Solution. This is called the you can say it as a root of this. We never use root for linear equation, obviously, but you can say it
Mm.
as solution or root, whatever. Okay.
Yes.
Or in graphical terms, this is the part where it is cutting the x-axis. Okay. This is the point where it is cutting x-axis. Why? Because you have taken, if I consider this as function y is equal to ax plus b, I have taken y is equal to 0, right?
Yes, sir.
And if I take y is equal to 0, y is equal to 0 is on the x-axis. You understand x-axis and y-axis?
Yes, sir.
So on x-axis, the y coordinates are 0. So if ax plus b is equal to 0, that means we are taking y is equal to 0, and obviously
0.
it will give us the point on x-axis. That means
Exactly.
if we are getting x is equal to minus b by a, the linear equation in one variable can be like here minus b by a, no? It is x is equal to constant, so it can be like this, and this can be our minus b by a, or it can be like this. This can be our minus b by a, depending on the values of b and
Yes,
a.
sir.
Clear?
Yes, sir.
This is the basic idea. We'll discuss in detail about the graph and the function when we'll discuss the function and graphs. If I
Yes.
have a similar question, minus 3x plus 4 is equal to 0, then find the value of
Mm,
x.
X is minus 4 by, okay, 4 by 3.
Yes,
Minus
x
minus
is
will get
equal to
2.
4 by 3. Very good. That means you have idea that how to solve linear equation in one variable. Let's go on
Yes.
discussing linear equation in two variables.
Yes.
Noted?
Yes, sir.
The why linear equation? Because the degree is 1. Why one variable? Because there was only one variable x. Linear equation in two variables. So if we have ax plus by plus c is equal to 0, this is the standard format of linear equation in two variables. Why? Because x and y are mainly variables, and a, b, c we always take them as the just some numbers at them places,
Yeah,
at their
yes, sir.
places, right? Like we can take 2x plus 5y plus 7 is equal to 0, like this. We can take like this. Okay. So here what I can observe, x and y are two variables. Can you solve this? 2x plus 5y plus 7 is equal to 0. Can you find the value of x and y?
No, sir.
Why?
Because we only have one equation.
Very good. So here you have to observe a logic. If you have one variable, you can solve it with one equation. If you have two variables, you can never solve it with one equation. You need two equations.
Yes.
Similarly, if you have n variable, you need n number of equation. Clear?
Yes, sir.
Okay. So if I give like this and I give some other, let's take an example. If x plus y is equal to 5 and 2x plus 3y is equal to 11, and I ask you to find the value of x, can you find now?
Yes, sir.
How?
So first I'll get x plus y. I'll do it into 2 so that it I can cancel out x,
Yes,
and
the elimination method. So there
yes,
are few ways. The first one is substitution method, right? You know the substitution method.
yes, sir. X is equal to 5 minus 5, and
And then
then
you will
instead of
substitute that part in the second equation. Very good.
yes,
So you are aware of substitution method and you are aware of elimination method. Solve by
yes,
both the methods and check whether you are getting the same answer or not. And these two are
yes,
enough. There are many more ways also, the cross multiplication and some other ways also, right?
yes.
The graphical method also. But these two are enough for us.
Y equal 1.
Do you have some book for cat?
Sir, my elder sister gave last attempt and she went to Time Institute coaching, sir. So I have those materials.
Very good. I also follow the time material. So if you
Okay.
have time material, it would be better.
Yes, sir.
But I'll
Yes.
also share some soft copy. I think the question might be same, or just values may be changed. Okay.
Okay. Yes, sir.
Because they have very properly arranged. When I prepared, I also followed the time material, and I think I have guided hundreds of students on those materials only.
Okay, sir. Okay. Yes, sir. X and y getting same value, sir, in both the methods. X is
Okay.
equal to 4 and y is equal to 1.
Very good. Correct. And whenever you get x is equal to 4 and y is equal to 1, you can check it. How? You just put it here, 4 and 1.
Yes,
If it is falling, then it's correct. If it is not falling, it's wrong, right? Here also put
yes,
4 and 1, 8 plus 3, 11. If it is a linear equation 2 variable, it must satisfy both the equations, right? Because you have got
yes.
the solution after solving both the equations.
Okay.
Okay, let's go further. That means we have idea about the linear equation 2 variables. Just have a bit idea about the graph also, very slight idea I want to give. Can I remove all this?
Yes, sir.
I will discuss about the linear function, but have just few idea. If you have an equation like x plus y is equal to 5, can you draw the graph of this? The answer should be yes. Here
Yes, sir.
we can just find few points and we can very easily, it's very easy. Whenever we have linear equation, whether it be in one variable or two variable, it will always represent a straight line,
Yeah.
remember. Okay, so here x and y, if I put at the place of y 0, I'll get 5. If I put at the place of x 0, I'll get 5. I have 2 points and 2 points are enough for tracing a line. So 5
Yes, sir.
comma 0, 1 2 3 4 5, 1 2 3 4 5. So this is 5 comma 0 and this is 0 comma 5. I can join it here. So this is joined and done. So this is the x plus y is equal to 5 equation, the graph, right?
Yeah.
Okay, this will help you in linear inequalities also, because there will be just slight difference, the arrow part will come here. This point is 5 comma 0 and this is 0 comma 5. Similarly, if I ask you to trace x is equal to 5 and y is equal to 3, can you trace?
Yes, sir. Like
Can
not on the line, but
hmm?
like it will not be on the line of the linear equation.
It is linear equation, no? It is actually linear equation. It will be a line, straight line.
Okay.
Whenever you get any, how, if I ask you, is this a linear equation or not? The answer should be yes. Why?
Yes.
Because the degree is 1. Degree is 1 means linear,
Yes.
and variable
Yes.
is 1. Linear equation in one variable, then obviously it will represent a straight line, right?
Yes, sir.
Okay. If you have to draw some points, because for tracing a line you need 2 points, you can do something like this. If you there is no y, na? If there is no y, what you can observe actually, that here is something like 1x plus 0y is equal to 5, right?
Yes, sir.
Y is missing. Why? Because some constant like 0 has come and just remove the y part. So if I put at the place of y anything, suppose 5, I'll get x as 5 only. If I put
Yes, sir.
anything at the place of y like 3, I'll get again 5 only, right?
I
That means for 5 also 5, for 3 also 5. Clear?
Yes, sir.
So I'm getting 5 comma 5. 5 comma 5 should be somewhere here, and 5 comma 3, 5 comma 3 I'm getting somewhere here, and if I join these two lines, I'll get a line like this.
Yes, sir.
So there is an observation, and we'll discuss in coordinate geometry also. I think I didn't mention about the coordinate geometry there, but we will discuss.
Yes.
Here we are getting this point is 5 comma 5, this point is 5 comma 3, and what we can observe, that whenever we have x is equal to constant, this kind of expressions, x is equal to something, so it is always a line parallel to y-axis,
Yeah.
correct? And there is a point, you'll just pass it with. And now
Yes.
if you want to trace x is equal to minus 3, you won't take that much time. 1 2 3, and just you will draw a parallel line to y-axis. This will be your line. Clear?
Yes, sir.
Very simple. Similarly, if I ask you to trace for the y is equal to 3, you can observe it similarly. Here, if you put any value of x, it is not going to change y, because
Yes, sir.
the expression is 0x plus 1y is equal to 3. If I take x is equal to 1, then also I'll get 3. If I take x is equal to 0, then I'll get also 3. So 1 comma 3 and 0 comma 3. So 1 comma 3 means somewhere here, and 0 comma 3 means somewhere here. 2 points are enough to trace a line, and we are getting a line like this, right?
Yes, sir.
So this line is representing y is equal to 3, and whenever we have y is equal to constant kind of line, it is a line parallel to x axis. Remember this part, okay?
Yes, sir.
And this line is x is equal to 5. So that's all for the discussion of linear equation, okay?
Yes, sir.
Now we can move on to our important topic, the first topic of, say, the algebra, the quadratic equation, and we can discuss in detail. Noted all these parts?
Yes, sir.
Okay. One more thing, if you have to trace somewhere, suppose y is equal to minus 5, what you will do simply, 1 2 3 4 5 in the negative side, and you can just draw a line parallel to the x-axis. Done. This is your y is equal to minus 5 line. Clear?
Yes, sir.
Okay, very good. Let's go further. Did you get all the concept that we have discussed till now?
Yes, sir. I have.
We started from the very basics, and we have discussed till now the linear equation part, the one variable, or say the two variables. Now
Yes.
we are going to our first important topic of algebra that I mentioned, the quadratic equation. Quadratic equations.
Yes, sir.
Okay, one more thing that I didn't discuss, the HCF and LCM part of basic algebraic expressions. Okay, let's discuss HCF and LCM. You understand HCF?
Yes, sir. Highest common factor.
If I give an example like, you have x minus 3 whole square, and you have another factor as x minus 3, okay, x minus 5 into x minus 3, what will be the HCF of this part?
X minus 3.
Very good. What you did?
Uh,
What are
like
the
whatever.
common parts, right?
Yes. Yes.
So x minus 3 is present here, x minus 3 is also present here. So you will take the highest part that is common to both, right?
Yes.
If I take here x minus y whole to the power 5 and write here x minus 3 whole to the power 4, then what would be the HCF?
X minus 3 whole to the power 4.
Very good. Very good. And if I ask you the LCM, then
X minus 3, I
just
think.
x minus 3. No, LCM would always be bigger one. HCF is smaller and LCM is a bit bigger. The name is different, lowest common multiple, but it is multiple actually, no? Multiple is
Yeah.
always greater, that kind. If I ask you the multiple of 5, what it would be? 5, 10, 15,
And
20, these kind. That means multiple increases. If I ask you to find the suppose factor of 5, you'll write what? 1 and 5 only, right?
1 and 5.
So
Yes, sir.
the factors will always be lesser, or at max it can be equal, right? But
Yes.
LCM can be minimum equal,
Mm.
or it can go at max whatever possible, right?
Yes. Yes.
So lowest common multiple would be, you will just observe the highest powers. Here we have x minus 3 whole to the power 5. Here we have x
Right.
minus 3 whole to, I'll take the highest one, x minus 3 whole to the power 5. Here
Yes.
we have x minus 5. Here we don't have x minus 5. So highest would be just x minus 5.
X minus.
So this is your LCM. Is this clear?
Got it, sir. Yes.
The same you apply in numbers also. Like if you have somewhere 96 and suppose 28, and I ask you to find the HCF and LCM. Find quickly and just connect the adapter.
Sir, LCM is 56. It's
LCM can never be lesser than any number.
it is 56, I think, sir.
LCM can never be lesser than any.
Oh, okay.
Here it is 96. How you can take LCM as less than 96? It should
Oh,
be
sorry,
common
sorry.
multiple.
No, actually, sir, I thought that was 56, sir.
Okay.
5, 6, and
Okay.
2, 8. So I
This
told
is
56.
9x. This is 9x.
Yes, sir.
Okay. If you considered it as 56, then it's correct. But here I have given 96. Check.
Yes, sir. 28, 56.
Find the HCF and LCM both.
Yes, sir. 1 second.
Done? Hello.
Yes, sir.
So what would be the
Continue, sir.
HCF?
Once I just finished the LCM, sir, the LCM of 96 and 28 would be uh, 672, sir.
672.
Yes.
LCM.
LCM.
What you did?
I did the 28 and 96 in a bracket and then
Okay,
divided by
okay,
2.
got it. You followed this process. 28, 96, and you factorize it like this: 2, 14, 48, right?
Yes, sir.
Then 2, 7, 24, and that's it. So you'll
Mm.
get 2 times 2 times 7 times 24, right?
Yes, sir. Yes,
So
sir.
this is 28 times 24, and this is 28 times 24. So we'll get 28 to 40, 48. So 192, correct. 19. So 48, 68, 67, correct. 672. And HCF?
I think it is 4, sir.
4. What you did in
Yes,
this?
I just did it mentally, sir. Like there are no other. I don't think there are any higher factors that are common more than that.
Very good. If you are able to do it mentally, then it's way better. But
Yes.
let's check it manually also. Here 96, we can take the factors. 2, this will be what? 48, then 2, 24, then 2, 12, 2, 6, and here 2, and then 3, right?
Yes.
And if we factorize 28, so 28 would be 2, 14, 2. This will help you in this factorization part will help you in quadratic equation also. 7
Yes.
1. So we are getting what? 7 is not there, so 2 times 2, yes, it is 4.
Yes.
Here you use this part to find the LCM, right?
Yes, sir.
You could have written like this also. Let's firstly write for the numbers. 96 we can write it as 2 to the power, what I wanted to observe, 1 2 3 4 5, 2 to the power 5 into 3, correct? And we can write
Yes.
28 as 2 square times 7, correct?
Yes, sir.
For HCF, what I said you, that for HCF you have to take the lowest part. Here 2 square, here 2 to the power 5. What it would be? 2 square. Here
2
3,
square.
here 7. Nothing common. So 2 square into 1, that's it. 4 is the answer. If you take for the LCM, you will take the highest part. Here you have 2 square, here you have 2 to the power. You will take it as 2 to the power 5. And here 3, nothing, that means 3 will be the highest. Here nothing common, so 7 will be the highest. So 2 to the power 5, 3 times 7. And it would
Yes.
be 96 and 7. 96
Yes.
times 7, 76. Yes, it is approximately 72. Clear?
Yes.
So you are clear that for the HCF we observe the lowest, and for the LCM we observe the highest power.
Yes. Yes, sir.
So that's all for the basic algebra discussion that we did today. We can go
Yes.
on quadratic equation. We can start the quadratic equation today also, but I think it should be enough for today, right?
Yeah.
You
Yes,
got
sir.
the
Yes.
basic idea. It would be better if we start in the next class,
Yes, sir.
right? So you got the idea that how our classes will go. We'll start from the very basic and just move on and move on. Okay?
Got it, sir. Yes, sir.
Very good. So how was the class?
Sir, I enjoyed it, sir. It was good, sir.
Okay. Okay then. So what would be your available time? I think you said that you'll be available every time except 5:30 to 8:30, right?
Yes, sir. Yes, sir. Just those 3 hours. Except that anytime you can tell, sir.
Okay. So I'll check. I think we can keep as of now in the morning, but
Yes.
if possible, we'll finalize it. Okay. Okay,
Yes,
Ayush.
sir.
That's all for today.
Yes, sir. Thank you,
Okay.
sir. And sir, anything about the fee structure, sir? Like, what
Uh,
would be your standard estimated fee, sir?
I think I should stop the recording 1 second.
Yeah.